Well, hello there again today, fourth graders. We're going to continue in chapter 13. We're on page 735. Halfway through this chapter, this is the mid-chapter checkpoint. On 735 and 736, and we're basically working with perimeters and areas. And so let's just go through this review real quick here. Initially, it starts off with some vocabulary. A square that is 1 unit wide and 1 unit long is a square unit. 1 by 1. Number 2, the blank of two-dimensional figures can be any side. The blank of a two-dimensional figure can be any side. The base can be any side. Number 3, a set of symbols that expresses a mathematical rule is a formula. And number 4, the blank is the distance around a shape. And of course, the distance around a shape is its perimeter. Problems 5 through 7 are asking you to figure out the perimeters. The first one is a 13 centimeter square. It's 13 centimeters on each side. So if you add all four sides, the dimensions of all four sides together, your answer would be 52 centimeters. That's the distance around that. The other two problems are pretty much the same. They're rectangles though. Number 7, it's 8 inches on one side, 15 on the other. So 15 and 8 is 23, and the other two would be another 23, so 46 would be the perimeter around that. 8 through 10 though, it gets a little trickier there, and I'm going to pick, I think I'll pick number 9 to do, because they want you to find the area of those combined rectangles. Remember yesterday we talked about how you can take a shape, break it into a variety of rectangles. This shape happens to look like this. We have an 8-meter dimension across the top. This dimension here is 5 meters, as is this side as well. They're both 5. They're the same. Each one of these is 2. And the only missing dimensions we've got 4 meters here, and then these two sides, they are 4 meters. So when you look at a shape like this, you got to decide, well, where am I going to break it? The first thing you need to figure out is, what is this dimension? Now, you know that from here to here is 4, and from here to here is 5. So you just subtract the 4 from the 5. If it's 4 to here and it's 5 overall, that means that this dimension is 1 meter. And the reason I wanted to find that dimension is if I cut this into 3 rectangles like that, these rectangles here would be 2 times 5, 2 and 5, and likewise that one's going to be 2 times 5. But then I got to figure out what this rectangle right here is. Well, we know it's 4 this direction and 1 that way, so it's going to be 4 times 1. Now, the reason I put this in parentheses is I want to do the multiplication before I do any addition. You don't want to add 5 plus 2 because that'll really mess up your order of operation. So anyhow, this is 10 meters plus 10 meters plus 4 meters. So 10 plus 10 is 20 plus 4 is 24. So your answer is 24 meters, and because it's area, that'll put a little 2 up there, indicate that it's square meters. You shouldn't have any problem with the other 2 problems on that page, because you solve them the same way. Just break them into 8 would be 2 rectangles. 10 would also be broken into 2 rectangles. And you just got to figure out what the dimensions are, multiply those dimensions, length times the height. Length times height equals area. Now, page 736. You've got 4 images there, and it's asking you which one has the greatest perimeter. Well, all you got to do is add sides together. So the first one would be 16 inches. Figure A is 16. Figure B would be 12 and 6, be 18. Figure C is a square, so there's 4 inches on each side. That would be 16, 4, 8, 12, 16. And figure D is a little bit smaller rectangle. 2 sides at 4 inches, 2 at 3. So you got 8 and 6, that would be 14. Find the total perimeters. Choose the one that has the greatest. Number 12, which figure has an area of 108 square centimeters? Well, you're just going to have to do the math. 6 times 13. 6 times 3 is 18. 6 times 1 is 6. Plus the 1, that one's 78. The 11 times 11, that's 121 centimeters. 11 times 10 would be 110 plus 11, 121 centimeters. So that one's too big. So it's one of the other 2, either figure C or figure D. And all you do is multiply the length times the height. One of those is going to equal 100 square inches. Let's see if you can figure out which one it is. Now, number 13. Gee whiz, they really want to mess with you. Which of the combined rectangles has an area of 40 square inches? Or, I'm sorry, 40 square feet. And what you're going to have to do, you're going to have to work through all 4 of those and figure out which one actually comes to 100 or to 40 square feet. Now, we'll just pick one at random here, and let's do figure C. I'm just going to pick that one at random, and we'll solve that one and see if it comes to 40. And if it doesn't, then you'll at least know that C is not the correct answer. So there's our shape. And our dimensions are 9 feet, 6 feet. This is 6 feet. This is 3. This is 3. And this is 3. And that makes sense because from here to here is 3. So from here to here, 3 plus 3 equals 6. So we know that's right. Now the first thing I see is I see a side here that's 6 and a side here that's 6. That's telling me there's a square. So I'm going to make my rectangle, I'm going to break it right there. Because I know this is a square, so it'll be 6 times 6. So this one's going to be 36 feet squared. And then this is 3 this way and 3 that way. So it's 3 times 3. So that is 9 feet squared. 36 and 9 equals 45 square feet. That is not 40. So you know that figure C is not the correct answer. So you just need to do the work on A, B, and D. One of those 3 will come out to 40 square feet. So go ahead, challenge yourself a little bit, work through this, and just to let you know, this is real world math. This is stuff you're going to use. You may not believe it right now, but I guarantee you that somewhere in your life, you're going to either need to figure out the perimeter of something or the area of something. You may want to put a border around a garden, and you need to know how much border you have to buy to go around that perimeter. Or you may want to figure out how much tile or carpet you want to put in your house in one of the rooms, and so you have to multiply those dimensions together to know when you go to the store how many square feet of carpet you have to buy. Trust me, this is real world math. You will use it. So go ahead, spend a little time and learn how to do it. Starting tomorrow, oh boy, finding unknown measures. In other words, you're given certain bits of information about an object or a shape, and you have to find a missing number. Now, what I like about those problems, it's kind of like a riddle, where you got to kind of figure out the answer to the riddle. And I know you can do it. So that's it for today, kids. Good luck with your mid-chapter review on 13. We're getting pretty darn close to the end of the book here. As a matter of fact, chapter 13 is your last chapter. So we're almost done with this textbook. Y'all have been working hard. Keep up the good work. Take care of yourselves. Be safe. Happy Ramadan to you today. Stay out of trouble. Shouldn't have to say that. Be kind to people. We'll see you tomorrow.